Hello guys, welcome again to the show of a massive quality mathematics where we abuse maths by finding solutions. Today I will take you through more examples of solving homogeneous differential equations with constant coefficients. So without consuming any time, we can just go into them. So you can see that we have two examples that I want to do for you today. Number A, second order derivatives, y second order plus 5y equals to 0. So let's start by number A, y plus, as usual, you have to find the auxiliary equation or the characteristic equation of this differential equation. The auxiliary equation will be replacing derivatives by m square plus 5 equals to 0. Because there's no derivatives, that's why we say plus 5 plus constant. So these are differential equations worth knowing. So we can solve for m. This will be m square equal minus 5. We can take the square root, both sides of the equation. This will be m equals to plus or minus root of minus 5. Since you know that root of minus 5 does not exist or is a non-real number or is an imaginary number, this leads us to the world of complex numbers, where this problem is classified as conjugate. This root is a conjugate complex root. So I can say m1 equals to square root of minus 5, or m2 equals to I can say m1 equals to square root of minus 5, or m2 equals to minus square root of minus 5. I can write this as minus square root of minus 1 times square root of 5, or m2 equals to square root of minus 1 times square root of 5 by using an exponential laws. So in the field of complex numbers, we introduce what we call I, where we see the square root of minus 1 are going to replace by I. So this will be m1 equal I times square root of 5, or m2 equal minus I times square root of 5, m1 equals to square root of 5I, or m2 equals to minus square root of 5I. So we can let m1 to be alpha plus beta I, or someone can let m2 to be alpha minus beta I. So you can just compare m1 and m1 to get the values of alpha and beta. So I can write m1 as 0 plus root 5r. Someone can choose to deal with m2, there's no problem. So you can just compare m1 and m1. You can see that alpha will be 0, beta will be square root of 5. So the type of the general solution that we want is as follows. Since I'm running out of space, I will erase the first pass. So the type of general solution that I want is y x equal c1 times e to the power of alpha x plus times cos beta x plus c2 times e to the power alpha x times sine beta x times beta x. So where there's alpha, I'm going to put 0, and where there's beta, I'm going to put square root of 5. So this will be y of x equal c1. When you put 0 here, it will be e to the power 0 times x, which is any number to the power 0 is 1. This is just c1 times cos, where there's beta, you're going to put root 5, just root 5x, plus c2. Similarly, where there's alpha, you're going to put 0, 0 times x is 0, any number to the power 0 is 1. So it's c2 times sine, where there's beta, you put square root of 5, though this is root 5x. Thus, the general solution of that problem is c1 times cos square root of 5x plus c2 times sine square root of 5x. So let's move on to number B, second example. So as usual, you will have to find the auxiliary equation. In this case, which is 2m squared minus 3m plus 5 equals to 0. So I would like to use the quadratic formula to find the values of m, or the roots. M equal negative b plus or minus root b square minus 4ac, all divided by 2a. Where there is a, you're going to put 2, b you're going to put minus 3, c you're going to put 5. This will be m equal, where there is b you're going to put minus 3. This will be minus into minus 3, which is 3, plus or minus square root of minus 3 squared is 9, minus 4 times 2 is 8. 8 times 5 is 40. It will be 9 minus 40, which is negative 31 over 4, because 2 into 2 is 4. Now, this can be written as m equal 3 over 4 plus or minus root negative 31 over 4. So, because you can see that square root of negative 31 does not exist, so this lead us, or is a non-imaginary number or a non-real number, so this lead us to the field of complex numbers, where we must introduce I by replacing everywhere where the square root of negative 1 by I. So minus 31 can be written as square root of minus 1 times square root of 31. That means where there is square root of minus 1, you're going to put I. So this will be m equal 3 over 4 plus or minus square root of 31 I over 4. You know that we let m to be alpha plus or minus beta I. So plus or minus beta I, you can separate them and have m1 equal alpha plus beta I, or m2 equal alpha minus beta I. So by just comparing, you can see that alpha is 3 over 4. You can see that alpha is 3 over 4. Sorry, you were not, I was hiding something, guys. Sorry. So alpha, it will be 3 over 4, or beta will be square root of 31 over 4. By just comparing, guys, you can find that alpha is 3 over 4 and beta is square root of 31 over 4. So the general solution that I want will be of this form: y equals to c1 times e alpha times cos beta plus c2 times sine. So where there is alpha, you're going to put nothing but 3 over 4. Cos, where there is beta, you're going to put square root of 31 over 4 x plus c2, where there is alpha, you're going to put 3 over 4x times sine, where there is beta, you're going to put square root of 31 over 4x. Thus, this is your general solution of that differential equation. So I hope this did something to you. You can support me by subscribing, liking, and sharing my videos. I really appreciate your attention and your time for viewing this. Thank you, guys.